Hi, everyone. Welcome. Glad you could make it. It's a real nice incentive for speaking. You get to take your mask off for about 30 minutes. So I have new appreciation for it. We're here today to talk about data-centric development. My name is Brian Platts. I'm co-founder, co-CEO of Flurry. Flurry is a zero-trust knowledge graph database. So I'm very dedicated towards concepts around data management. And I'm very passionate about the idea that we need to start approaching our projects within our organizations a little bit differently than we have been doing for some time. And it's due to the rise and importance of data. And I think that's something obviously we can probably all agree on, is that the role of data in our organizations has changed and is becoming far more important, and I think will continue to become far more important. And we struggle with it. This is, it's estimated that application integration, which is mostly data integration, now consumes about 50% of IT budget. We have a hard time getting to the data we need to move our organizations forward, and it's only getting worse. Peter Zaitsev, in his talk this morning, which I enjoyed, he called databases the plumbing of the house, something that's kind of sitting in the background, but when you have an issue, you have a big issue. And I've never heard that analogy, but I really, really like it because I think it echoes part of the issue. If data is becoming more and more important in our organizations and what we do, then we need to think about it in a different manner than it's sitting in as water or whatever in the plumbing. I also like the analogy because I think about if data is the plumbing, then what are the APIs? How do you get access to it? And I think those are the sinks and the toilets in your house. And if someone needs access to it, you're developing something new, and they always work a little bit different, just like APIs. And just like that leaky sink, APIs need to be maintained over time. So there's an expense of having them. And that, I think, is also representative of some of the challenges that we have today, is building and maintaining APIs and really understanding the true cost and of maintaining them over time and ensuring the security. And so if databases are also the plumbing of the house, then what is the data lake? It's probably the sanitation plant, right? It's where everything comes together. And probably similarly, there's probably only a handful of people in your organization who can really handle dealing with that crap. There's just it's a very difficult problem to manage. So I like something that we've seen at least Gartner start to talk about, which is we've traditionally looked at some of the challenges of business and differentiation for business as revolving around three things. This has kind of been, anyone who's been to business school was taught these three things. There's people, process, technology. And business differentiation is in one of those three areas. And I like that Gartner actually came out here very recently and said that they believe there's now this fourth pillar of differentiation that is becoming critical and will be critical to businesses' success, and it's data. And not necessarily at the middle, as is represented here, but one of those, as important as it is hiring the right people to your organization to differentiate your company, is how you manage and deal with data. So how do we shift our organizations to start working through some of these challenges? And that's what we're going to talk about here a bit today, and actually use some tangible examples, use some fun examples like verifiable credentials. I don't know if, well, I'll ask, has anyone worked with or aware of or played with verifiable credentials here? A little bit, okay. I like to call them secure data containers, and I think they're really just going to change a lot of how we work with things in the future. So how does something like that fit into this role? How do we start thinking about data from a data first standpoint? So this is kind of what we build today. We have usually, an app, and it's got some GUI or UI, and then of course there's the app server, and that's where we'll put a bunch of our APIs to get access to data and do other things. And then we have the database. And part of the challenge of the database is that the people who build the database are the same people who build the app server. Not that that's a challenge, just that it was a secondary thing. It's something that I need the app to do X and I need to maintain some sort of state to do X. So I'm just going to write whatever we want into that data. And it's no surprise that all the databases describe data differently and lead to some of these challenges we have. In fact, lead to, I think, data warehouses and data lakes, which originate out of the need of pulling all this together so that you can issue a query across information. And of course, we don't just have one, we have many. Recent stat I saw is even a mid-sized organization now has over 500 software as a service applications. So the problem's getting worse. We have data everywhere, it's duplicated everywhere. So we try and solve some of it with data lakes, and of course there's more and more data lakes and data lakes, and everyone's got their own data lakes, which is really just a bigger data silo at the end of the day. So where we hope we can move to is a data-centric approach, where we're starting to think about the data first, not as a after the fact thought on maintaining state for our application, but how we actually strategically set up and manage data and describe data so it has a better opportunity. I think from an organizational standpoint, we're probably have a lot of data at this point. We collect a lot of things. We can just throw it in Glacier or S3, so it's pretty easy to leave it laying around. But if it's not getting used, it's just a cost center. So the concern we should have is not necessarily how much data we have, but how do we activate that data? And then activate that data not only within our organization, but across organizations. And that's what companies have to start getting really good at to remain competitive. So when we think about data-centric apps, this is at least I think a better view of it. Instead of a GUI on top of an app server on top of a database, we're looking at apps that might be leveraging simultaneously multiple data sources that maybe aren't even fully in your own organization. They don't all have to be together in one place to power something like an app. They don't have to exist as a gigantic data lake or data warehouse. We should be able to pull data sources together at the query level. So the query can define joins across data sets. So this is what we're talking about when we're talking about data-centric development and data-centric apps is moving into this world, and then what kind of technologies do we need to think about and be familiar with as we're moving into this world. So one last slide before I get into some examples. And if anyone has questions, by the way, just feel free to raise your hand anytime. I'm happy to jump in and address them. This is a chart. This actually uses, I'd say, real data, but data from legitimate sources as far as different costs of doing things around application development. So what we see in the green is that if an average organization needs to build a new app, nowadays it costs about $175,000. So that's about the investment that an organization can think about making into building an app. But now, once I have that app, if I find the data inside of that application needs to be used in other contexts, that's where the costs really start wrapping up. And everything in the blue here really represents those different components that start to add to the cost of that, simple $175,000, wasn't cheap, but $175,000 app. And that includes how do we get access to that data and keep it updated in external sources. Probably needs to go into a data lake or data warehouse. That's the next little block there. We have data sharing. We need to build APIs. Other things need access to that data. It's estimated that it costs $20,000 to $30,000 to build an API. And then the piece that isn't often budgeted for is that it's recommended that you spend about half of that every single year to maintain it. And if you don't, you can end up with some issues. In fact, in financial services companies, APIs are where the majority of the data breaches are now happening. And mostly it's because it was secure when it was built. It's just the data models changed a whole lot, the apps changed a whole lot, and nobody's really invested in making sure that it remained secure and remained doing what it was doing. So, hackers take notice, and of course they go after the places where they feel like they can get their easiest access on data they shouldn't. And it turns out APIs is becoming that location. The other cost and the final cost in here, which I often think is the most overlooked part of API development, is it's not only your cost of building and maintaining it, but you actually impose that cost on everyone who has to use it. So everyone who has to use it has to build a proprietary interface to your proprietary API. And it's estimated it costs them about $15,000 to $20,000 to do that, and then they need to maintain that over time. So if you have 100 users of your API, you've just imposed on your customers an aggregate, $200,000 of cost on them. So there's standards-based ways that we can get to data easier. It's just the way we treat data in databases, it was never designed to do it. Things like SQL. Everyone knows SQL. If you can just describe the data you want, why wouldn't a SQL query be a pretty good API? GraphQL, I think, has recognized this problem of all these APIs and is trying to create one gigantic API that under the hood is going to issue all kinds of different queries to get to what you want, but at least you're maintaining one API at that point. And so I think we see a lot of movement towards this, but I think in big part, it's addressing this key issue that, just explosion of APIs is incredibly costly, is creating data breaches, and just is not maintainable. So I believe there are some better ways at approaching this, but we need to think again about how we're dealing with data a little bit differently than how we've thought about it in the past. So I like to contrast a little bit on how we think about data from, an application-centric world, which is kind of the world, again, that we've had and been living in, to a data-centric world. What are some things that have to be different? And I recognize, especially since this is a big room, it's probably a little small, but I'll read at least a few of these. So one is the interaction model. When you think about a traditional database and a traditional application-centric model, it was designed for one-to-one interaction. There wasn't really any, slot that the database was ever going to get used by anything except for your application server. So all of the interaction and all the paradigm around a traditional database is really based on that. There's one consumer of the data and one producer. And if multiple people need the data, that's why you build APIs, right? So you're going to expose it from your app. But your app is still really the only thing that was ever designed to talk to the database. And if you need some of the data out of it, too, for something like analytics, that's where the data lakes and data warehouses come in. But they kind of come in through the back door, they rip everything out, and you've lost all the business logic because that all sits in custom code in your app server. So when we think about data centricity, what we need to think about is a many-to-many model. So you can have a database. I like to think about, as uncomfortable as sometimes I think it makes me feel and other people feel, is that a database in this sort of world, in theory, should exist on the public internet, because it should allow anyone, your partners, your customers that have access, so security should be there, to be able to update data and maintain data. And of course, any number of consumers. Again, data-centric apps, right? There's a lot of apps that the apps sit around strategically organized data as opposed to the absolute opposite, which is how we typically approach the problem, which is why we have some of the challenges we have today. So security we need to start thinking about differently, because in a one-to-one world, in an application-centric world, the security is sitting in custom code in our app server, because why not? I mean, there's only one thing it was ever designed to interact directly with that database or the data tier. It was your app, so it doesn't really matter where the security is. But in a data-centric world, and you're thinking about multiple applications actually interacting with, transacting, and querying centralized data sources, all of a sudden you need to think about security a little bit differently. And putting security into the data tier starts to become your best option. Because if you have 5 apps using the same data tier, then you don't want to have to rebuild your security rules into custom code in all 5 of those apps. You want data to defend itself. You want data to be able to understand those sorts of rules directly in that data tier. It's the only way it becomes scalable. Things like capacity planning. I mean, it was always hard to do, right? But at least if you only had one app server or, a cluster, load balanced of app servers talking to your data tier, you had some degree of control over your data tier. You can look at the queries, you can talk to the developers that are issuing those queries, say, hey, you need to improve this or change this, or let's, modify our tables in this way or that way. But in a world where you have many consumers of data, you need to think about scale and spreading out that scale much differently, because you don't have far less control over the queries. They might be coming from your customers or your partners directly into their systems. So how do you allow a system that can scale out? And at least for us, we think about this and allowing the database to actually exist anywhere in the world, so that people are running their own mini database servers that are keeping in sync, but the load that they're generating is on their own servers, not necessarily on your servers, even though we're operating on the same database. But you need to think about things like that, because it's a little bit different world and different sets of problems that you have to deal with. And just on the last one, how do you get access to the data? So today, we build custom APIs, but we need more native and flexible interfaces into that data if we're ultimately going to scale it. The other thing I think that's layering a new complication on this is privacy and trust. And we even have the government now stepping in. Of course, a lot of you have probably heard about GDPR in Europe, the Privacy Acts, but California has the CCPA. These are relatively new, but I guarantee within the next 3 years, you're going to start seeing even federal regulation around people's rights around their data. A regular database never has had to deal with this sort of problem. The idea that you actually have data in your database, but you don't own it. Your customer owns that data, and they get to dictate exactly how that data is used. So these are things, of course, we can build a lot of sort of business logic that sits on top, but these are things that a modern data platform needs to really start considering. So we'll get into a little bit of tech. So what are some of the technologies that are being used for to address some of these problems? And I'll start out by saying these are the components that we feel a more modern data platform needs to be able to address. And I'm just going to focus on these first two, but the first two are trust, the idea that data has integrity. You can validate that integrity. The second is semantics, so that you have the ability to speak common languages so that machines can interact directly. We have security. We talked a little bit about that, the concept of data defending itself. If we have a little bit of time at the end, I might touch on a couple of these. Concepts of time become very important. How can you collaborate if you cannot lock in time? So when we collaborate around source code, we lock in time with GitHub or Git. But when we collaborate around data, which doesn't happen that much today, which is part of the problem that needs to get solved, we need similar mechanisms to lock in time so that we both have a common view of the world. If we can't have a common view of the world, we can never collaborate around anything. And of course, data sharing. So we'll talk a little bit about trust. So when we talk about trust, what are some of the key components that we're thinking about? And there's really three. I mean, there's probably more, but there's three things we want to verify with trust in the data tier. One is identity. Who put this data in there? Where did it originate from? So right now, there's no direct connection to that. This becomes more critical as you're sharing data, and especially as the data goes across boundaries. The next is data integrity. Has the data been tampered with, or do I know the data, is the way it was and has been? And then the last is data provenance and lineage. So how have things changed over time as it relates to these pieces of data? And I like to equate this capability that we need, because again, these are going to be machines interacting directly with machines that need to be able to read data across boundaries and dynamically understand what it means without us humans having to get in the middle and be able to translate or do ETL processes or move all this into a data lake or data warehouse. To me, this is the equivalent of the little green lock icon that comes up in your web browser that guarantees when you're on Google's site or Microsoft's site or Apple's site that the data you're looking at in your web browser really came from Apple. There's no way it's been tampered with. You're not getting spoofed. You're not getting tricked. This same mechanism needs to exist for the data world. So machines need to be able to independently validate the data they're getting from different sources hasn't been tampered with, and it really came from the place they think it is. Otherwise, we have a could have many significant messes on our hands, especially when we think about the machines taking this data. They're performing, they're running models on it, they're doing AI on it. I mean, this starts to open up an attack surface of actually, tricking machines into making different decisions, especially when we're interconnecting data across sources. So trust becomes just a real fundamental thing, just like HTTPS is a real fundamental thing that needed to exist for the web, for e-commerce and financial transactions. This world needs to exist for interconnected data across the web. And one of the fun areas, I think fun areas, I guess if you love data like me, you think some strange things are fun, but one of the fun areas that I think is going on right now is in verifiable credentials, which I just brought up. So I'll introduce the concept, but it really plays into these ideas. And a verifiable credential, I like to call them data containers. We talk about containerization of apps. This is really the containerization of data. And a verifiable credential is a self-describing data payload. So you'll see it in JSON, technically JSON LD, which we'll talk about here in a minute. But the data is represented in JSON, but it has some specific, semantics to it. But importantly, it is hashed and signed. So it's cryptographically signed to allow you to validate it. So where is this starting to get used? We're doing multiple projects with Department of Education, with some of the big universities to do this around student transcripts and degrees. It's a great example of a verifiable credential. You see Apple just introduced into the wallet in the latest iOS release, the idea that certain states are allowing the digital driver's license to start appearing in your wallet. Before long, you will have a wallet with more credentials in it by a magnitude than you have a wallet with credit cards or airline passes or anything like that. And they're going to be things that other people validate about you. And they're going to get represented in this way. They're going to get represented as a verifiable credential. This is the standard that has the steam to be able to do these sorts of things. And this is all about data centricity. This is data that exists outside of the context of an application, and there's no app server involved. It's an education example. This is a degree. It's a transcript. No app server. And it needs to be understood and validated by anyone who gets it. One of the exciting things about verifiable credentials is that we have the issuers on the left. So this will be like the university and a degree standpoint. And they actually give and issue the credential to the holder. So that's the student. So the student actually has it. And now this is privacy preserving. So we're not using blockchains to, well, you can do some interesting things with blockchain actually in this mix. But you're not trying to like store degrees on blockchains or anything like that. That'd be ludicrous. I mean, this is a student's degree. And actually the student should have the only control over who gets that and when they get it. And you start thinking about health records, you start thinking about financial records, all of them are going to be taking this same path, which is the owner. And you think about regulation, which I already mentioned. The owner of the data is going to have direct control as to how it participates. But these pieces of data still need to be connectable into this giant data graph that represents the world. And that's what verifiable credentials do. And then lastly, we have the verifier. So who the holder decides to give, in this case, the degree to. A logical place to give that to would be when you're applying for a job. Right now, when you apply for a job, depends on the company, of course, but they'll ask you where you went to college, and then as part of their usual background check, they'll validate that you really went to college there. And they hire third parties who call up the schools or do things like that to try to validate this information in some sort of background check. And here's a great example where this technology completely eliminates the need for that. Because any verifier, the employer should be able to validate that degree and know without a doubt that that degree's never been tampered with, and that degree was issued by UNC Chapel Hill. And no background check provider should ever have to be involved. So we can't do that until we start getting into decentralized identity, but we also need that trust, those proofs we talked about. We also need to know that that data hasn't been tampered with. So we do that, even when we wrap things with signature, we do it with hashing. Usually a SHA-2 hash might be a KAK or a SHA-3 hash, it doesn't really matter. The data gets hashed so it can be validated. And then a signature, usually asymmetric cryptography like ECDSA, elliptical curve, maybe an RSA signature gets wrapped around that data that then provides identity. So a data registry in this case does not technically have to exist, but it can exist to validate that the credential is still valid. So maybe you got issued a degree, but for some reason, the university, who technically owns the degree, you don't own the degree, just like you don't own your driver's license. The state owns the driver's license, but they give it to you. But the state can revoke your driver's license if you get too many speeding tickets. So that's where a third-party registry ends up coming into the loop, is that if I want to actually validate that this hasn't been revoked, I can do that. The other place a third-party registry in this scenario would come into is to validate what we call a DID document, a decentralized identifier, which is basically what holds the public keys of whatever signed the verifiable credential message. So that then I can actually say the decentralized identifier that signed this degree does in fact belong to UNC Chapel Hill. It is still valid. You know, they haven't revoked that identity. And I know that this, in this case, a degree is valid. But you think about the application for this type of technology. And I just recently refinanced my mortgage. I hope a lot of you who own houses did that with interest rates being so low. But you know, one of the silly things that kind of happens there is that a mortgage company, they need to call your employer and validate that you work there and validate how much money you make. Well, when you get a paycheck, you should also get a credential, and you should be able to supply that to the mortgage company, and they can independently validate that that's authentic and real. And really, what business is it of your employer to even know that you're applying for a mortgage? It's none of their business. And that's really one of the beauties of this, is it's privacy preserving. And that's why I like to call them data containers. They're just these mini containers that are verifiable and descriptive. So I'll hit on semantics. This is really the last core layer of this onion. In semantics, is anyone familiar with or played around with the concepts around semantic web technologies? A couple of you. In fact, you're probably like, oh God, I didn't walk into a semantic web talk, did I? It's either, you're either a passionate crew or you're not. The semantic web, you know, the origins were with Tim Berners-Lee, who's credited for inventing the web itself, but go back to 2003, which is where the concepts came from, and have really gained popularity in certain niches. In fact, you probably use this technology many times a day and aren't even aware you're using it, but we're just getting to the point where we're starting to represent data more actively at a data management tier in semantic webs. But this is this is real linked data. This actually comes out of Wikidata, but it starts to show, I mean, I like graphs like this because these are all independent data sources, but they all start to be interconnected. And right now, our only way of accomplishing and querying data that we're familiar with, that we have to, use to work in this plumbing model that we have today, is a data lake or a data warehouse. But here we can start connecting data, just like web pages connect web pages. We can start connecting data across sources, between companies, within repositories in the same company. But it all requires having to sit on semantics, having to sit on understandable vocabularies that can be shared across machines. Because if we don't have that, we're back to the ETL processes. We're back to the processes where somebody needs to sit down with the developer that created this SQL table and say, what does this field mean? What does this field mean? What does this field mean? Okay, we're going to translate that into X so that we can actually then, get this into a more usable format. So this is growing quite rapidly. There is an immense amount of data already out there, and every year it's quadrupling, if not more. So there's a lot of really useful information out there that can be connected if you're using this technology for your own data. So I'll give an example here. And in fact, we'll talk about JSON LD, because I really feel like JSON LD is the breakthrough that this technology needed. So this is an example of JSON LD. And hopefully you all can see it. This actually comes right off of schema.org's website for an example. One place where you might have used this technology is if you built a web page and you're trying to do search engine optimization. And you'll go and Google or Yahoo, or does Yahoo have a search engine anymore? Maybe they, who knows? They will tell you that if you embed metadata into the web page itself, that instead of it trying to have to figure out what the web page is from text or whatever, you can explicitly say, this is what it's about. This web page is about, this book or this movie. In this case, this is JSON LD data that represents Hitchhiker's Guide to the Galaxy, the movie. And I'll point out a couple things about JSON LD. So you might actually find code that looks like this embedded inside of web pages, if it talked about Hitchhiker's Guide to the Galaxy, but whatever it's talking about. And it's metadata that is self-describing. So when we talked about verifiable credentials, they also use JSON LD. If you worked with any of this technology previously, you might have used, if you're a web developer, you might have used RDFA. If you were someone who focused on knowledge graphs and analytics and insights and maybe came from the AI space, you might have used Turtle, which is a serialization format for this common data. Some of you may have heard of triple stores. Triple stores are a way of storing RDF data. JSON LD is a way of representing RDF data in JSON. And I think it's what is going to enable a lot of developers to on-ramp into this. And in fact, a lot of these standards, like verifiable credentials, actually use JSON LD. So even though someone who might have used JSON might be creating a verifiable credentials, they have never learned about or cared about the LD part, which stands for linked data, but they're starting to use it, and it's very accessible. So this particular payload of data has a few parts to it. The first part at the very top, and you'll see anything that starts with the @ symbol is the key here, has special meaning for JSON LD. But the very first part has the most special meaning, which is the context. And this is what describes the vocabulary that's being used to represent the terms that are in this JSON LD payload. And one of the nice things about this context is here we're just using schema.org. So we're saying we're using the schema.org vocabulary. And in fact, if any of you have optimized data for web pages, you've probably used schema.org. If you've ever shared a link to a web page on Slack or on Twitter, and you know how the nice little sort of subtitle in the picture comes up? That's because of linked data. You're probably using the Open Graph vocabulary to do that, but the unfurling of web pages is made possible by this. That's why I say you're probably using this, hundreds of times a day and not even realizing you're using it. And if you think about what's enabling it, it's metadata globally described on web pages that allows LinkedIn and Twitter and anyone else using this to automatically integrate. But they didn't build a direct integration to your web page. It's just because the data is self-describing, they can understand it. And this is what we have the opportunity to bring inside of our enterprise. The data being self-describing, integration happening automatically. That's the real potential here. So the context is going to say, this is the vocabulary that we're using. If we had our own custom fields here, that would be fine too. The context would be a map or a JSON object, which would map each term to the vocabulary term that it's using. But a lot of them are going to be simple like this. We're just going to be using schema.org here. The next one, the @ID, this is giving a globally identifiable IRI, or in this case, a URL to this particular item. So this is a unique way to say, I am talking about Hitchhiker's Guide to the Galaxy. When I say Hitchhiker's Guide to the Galaxy, it might mean a couple things. In fact, we even see a couple things in this payload. Based on the nested object here is also called Hitchhiker's Guide to the Galaxy, but it's talking about the book, not the movie. The top one's talking about the movie. So you'll see they have different @IDs because that's it's eliminating ambiguity. And this also means across data sets, if things are using these global IRIs to refer to items, all of a sudden we have joins across data that we don't have to directly map or use unique keys or anything to do that to. So you don't have to use a completely unique identifier, but it's recommended to use one because you get some of this magic. The next part of it is an at type. So this is classes. This is, you're assigning a class to your data. This top level node here, the type is a movie, which actually, because we're using the schema.org vocabulary, technically maps to https schema.org/movie. Again, even though we're using the shortened key on the left of just movie, that expands out because of the context, and we prefix that with the context. So now we have a universal way that we're referring to a class type. And then there's some fields here, the name, description, title EIDR, and then we see a nested object. So this is where it starts to get a lot different than MongoDB document or something like that, where this is actually a separate, like, relational entity. In this case, it's a graph, they're a linked entity, but this is a completely independent entity, and it is based on, it actually lists out some details for the book. And then we have yet another entity in here, which is the author, which is a person, at type person, which is Douglas Adams. So Douglas Adams wrote the book, and the movie is based on the book. So we have three entities that we're creating here. All of them are using classes. All of them are using a global identifiable vocabulary. And any machine should have enough information here to unambiguously know exactly what every field and value here means, what data types they are, etc. And in fact, schema.org is nice because if you go to their website, and here, well, I don't have the URL bar in here, but this is just schema.org/movie. And here is the full description of this data class of movie. And here's all the different fields that can exist on it, and here's how they're described. But another cool thing starts to happen in linked data, and especially this is one of the reasons knowledge graphs, which is all based on the same technology, is becoming so popular for AI and analytics, is because we now have classes in our data, we can have hierarchies, class hierarchies. And it'll be hard to see, but right underneath the movie title there, it says movie is a subclass of a creative work, and a creative work is a subclass of a thing. So you should be able to search for all creative works. And in fact, a book is a creative work as well. It's a subclass of creative work. So just in this one payload, I should be able to issue a query, say, show me all the creative works. And I should not only get the movie, but I should get the book. Or I should say, show me all things. And a person, which we also created, is a thing. And I should see three things coming back. So you think in a relational database, you would have to know ahead of time, if I was looking for creative works, well, there's books, there's movies, those are in a separate table. There's this, there's that. These are all in separate tables. And I'd have to, formulate a query that hit all of those tables to bring all this data back as a result. But this is really where the power of the knowledge graphs come from, is this, class hierarchy. And classes exist not only for items, or the hierarchy exists not only for classes, but hierarchy can also exist for properties. So you could have, a property called mother and a property called father, but they could be subproperties of parents. So I could issue a search and say, find me Douglas Adams' parents. Well, there might not be data in the system that actually said they were a parent, but the rules of the vocabulary here automatically know that a father or a mother are actually parents. So you can start to imagine some of the power in connecting data and some of the analytics insights that you can start to get once you start leveraging this. And I'll come right back, or as the last thing here, hit the, using some of the foundation we just used. This is a verifiable credential of a degree that was issued by a university. So it's a little bit smaller here because there's more in here, but we have at the top a context. And in this case, instead of using schema.org, we're actually using a couple vocabularies, but primarily we're using the w3.org credentials spec or vocabulary. So there's our reference to the vocabulary that's being used in this payload. Again, multiple vocabularies can be used, so you can really make this as involved as you want. The whole first part in the green here is just describing metadata. So we have an ID, a globally unique identifier for this particular credential. And we have a type here as well, which we're saying this is of type verifiable credential. This would what it would allow a machine to automatically know. This is a verifiable credential about something. In the blue area here are the claims. This is what we're asserting. In this case, the claim is a degree. It's a bachelor degree that's being asserted. And then lastly, in this pink area is the proofs. So this is where the the signature is gonna happen. So this, again, using JSON LD, is what a verifiable credential looks like. And this is what allows any entity receiving a verifiable credential to independently understand exactly what it means and independently verify that it's never been tampered with and independently verify who issued it, which is why we're going to start seeing a lot more of these. So the layers that we're really not covering here are security, the ideas of data defending itself, time, which is a real favorite topic of mine. I have some talks where I only talk about time and some of the problems that just disappear when you can wield time, when you have time travel with your data. But in the context of creating data ecosystems and data-centric development, time becomes very important for collaboration. Again, in the identical way, you need to be able to look at your databases like they're Git repositories. You need to be able to know what it was at a certain moment in time and those commits and that they're valid. And time becomes important in that. It also happens to solve a ton of other problems we often deal with, like a lot of nasty race conditions, microservices architecture conditions, integration issues. There's a lot of things that just kind of disappear when you have immutable databases in time, which are pretty cool. And last but not least, sharing. Now that we have this valuable data, how do we express and allow people to, in apps, to combine across these multiple data sources dynamically without building more APIs, without writing a huge GraphQL interface that's hitting a bunch of underlying databases. So those are some other kind of layers that come to this. So go ahead and conclude there. Some ideas to get started. I think verifiable credentials are really cool. They have the perfect mix of buzzwords. You see a lot of things going on in them right now. I think if you like digging into this stuff, verifiable credentials is a fun place. You're going to hit on linked data. You're going to hit on JSON LD. You're going to hit on the cryptography. You'll very often they're associated, although they don't have to be, with registering identities on blockchains. You're going to get a little bit into the crypto space. I think it's a fun place to dive in. Of course, Flurry is an open source database that does all of these things, and we have lots of examples and tutorials there. So checking out Flurry would be another good option. Looking at different triple stores, there's some like under Apache, there's Apache Fuseki. There's some commercial offerings in the triple stores, AnyWork into knowledge graphs. These are all the kind of core concepts that we're talking about here. And I think things that are going to be important for most developers to know in the coming years as data's role continues to outgrow that of building apps. So that's it. I'd love to take any questions if anyone has any. Yeah, so the question is, do we see verifiable credentials getting uptake in the market? Yeah, absolutely. A lot of it we're seeing in kind of proof of concept stage, but I brought up Department of Education. They're very focused on verifiable credentials, not only as a way of taking a lot of fraud and churn out of the education system, but actually changing the education system. And that's what I think a neat thing that can happen with some of this technology. Their thought is that they've kind of created an education system that has people who have 4-year degrees and people who don't, and that the employment sector really looks for that. So there's a lot of other careers and opportunities for people in this country that fit in between those things. A lot of skills, even cybersecurity right now. You see a lot of 1-year or 2-year degrees that might get you some of the basic skills you need without needing a 4-year degree. So if we're going to start kind of breaking down the education system and changing the education system in the US, we start to need a way for technology and wallets to prove you've done certain things, even if it wasn't, I went to NC State or UNC Chapel Hill, but maybe I have a specialty program in here and I've done this and I've done this and I have these life experiences. These all create my degree, which is a lot different than a 4-year degree. So I think that's very exciting. I think they recognize that the education system in the US is, a bit broken and we need to fix it. And they're actually looking at this technology as a way to do it. US Customs and Border Control are looking to use verifiable credentials to prove the supply chain of goods coming into the US to be able to expedite things, but not only know, because credentials can be wrapped. They're like those Russian nesting dolls. You can have a credential and someone else can wrap your credential and add additional data and additional data and additional data. And you can obviously picture supply chains like this, anything from, the farmer, the seed, the farmer, the processing, all of these end up in a verifiable container, a set of proof that could then be presented to something like Customs and Border Patrol, who now has a lot of very detailed verifiable information and can process things. Maybe even coming in more importance here is we're having all the supply chain issues. Financial services, healthcare records, owning your healthcare records and transportability of healthcare records. Absolutely, verifiable credentials I think are going to, they're going to be very ubiquitous very soon. A lot of people are using it for vaccination status. That's a really good question. And in fact, in Europe, that's actually what they're doing. They're wrapping a lot of the vaccination status information in Europe up in verifiable credentials for exactly this reason. And partially because of that, actually, I'd say Europe's a little bit ahead of the United States in issuing verifiable credentials and recognizing their potential. But yeah, it's a little bit more of a political issue here in the US. So. Thanks, everyone. I appreciate you coming.